this video, we are going to talk about how to integrate trigonometric functions. So we are going to talk about how to integrate functions of the form sine A cos B dx, and also functions of the form sine B cos A dx, and also functions that are also of the form sine A sine B dx. And then the last one is functions in the form of cos A cos B dx. Now, what is the derivative of sine x? If we differentiate sine x, we get cos x. And what is the derivative of cos x? If we differentiate cos x, we get minus sine x. So this implies that, now based on the fundamental theorem of calculus, I have already done a video on it and I'll link it in the description. So based on the fundamental theorem of calculus, we know that integrations and differentiations are directly opposite. So this implies that if we integrate cos x, if you differentiate sine x, you get cos x. So if you integrate cos x, you get sine x. So the integral of cos x dx is equal to sine x. But then because this is an indefinite integral, then we need to add a constant of integration. So it becomes sine x plus c. And if we integrate sine x, you see that there is a negative sign here. So in order to remove the negative sign, we need to multiply this one too by negative. So integral of sine x dx is equal to minus cos x plus c. Now, what if instead of cos x, it was of the form integral of, cos nx dx? How will you integrate this? So what we will do is that, you see that when we differentiate, let's differentiate d dx of sine nx. You first differentiate what is in this bracket. If you differentiate that, you get n. And then you differentiate the whole function. If you differentiate sine, you get cos. So it becomes n cos nx. So it means that now, so it means that to integrate cos nx, if you divide through by 1 over n, and then you integrate cos nx, then the integral of cos nx dx is equal to 1 over n and then sine nx plus the constant of integration. So in that same fashion, integral of sine nx, so you see that here was 1 divided by the derivative inside the bracket. So it's equal to, if you differentiate nx, you get n. So it becomes 1 divided by n. Then if you integrate sine, remember what we said, if you integrate sine x, you get minus cos x. So it becomes 1 over n and then times minus cos nx. So if we further simplify, it becomes minus 1 over n cos nx plus c, where c is the constant of integration. To be able to integrate functions of the form integral of cos A sine B dx and then like forms, what we need to first look at is the expansion of sine A plus B, sine A minus B, cos A plus B, and cos A minus B. So now, what is sine A plus B? This is sine A cos B, then plus cos A, and then sine B. And then let's do sine A minus B. So this is sine A cos B then minus cos A, and then sine B. So you see that for these two, if we add the two equations, so let's assume this is equation 1 and then this is equation 2. If we add equation 1 and equation 2, you see that this part of that equation will vanish. So it becomes sine A cos B plus sine A cos B is 2 sine A cos B. Then that is equal to sine into bracket A plus B, and then plus sine into bracket A minus B. So if you divide through by 2, then it implies that sine A cos B is equal to 1 over 2, then big bracket sine into bracket A plus B, and then plus sine into bracket A minus B, bracket close. So let's do the same for the cos function. So what is cos into bracket A plus B? It's equal to cos A cos B, and then minus sine A sine B. Now what about cos into bracket A minus B? It's equal to cos A cos B, then plus sine A sine B. So you see that in that like manner, if we add these two equations, so let's say this is equation 3 and this is equation 4. So if we add equation 3 and then equation 4, you find out that this side of the term will go away. So cos A cos B plus cos A cos B is 2 cos A cos B. So 2 cos A cos B is equal to cos into bracket A plus B, then plus cos into bracket A minus B, and therefore cos A cos B is equal to half of into bracket cos A plus B, then plus cos A minus B. Bracket is here. Now, instead of adding, what if we decided that we'll subtract equation 3 from equation 4? So let's do it here. Equation 3 minus equation 4. So you see that, let me rather do it equation 4 minus equation 3. So you see that we are going to subtract this one from this, and then this side cos A cos B will go to 0. So it becomes now sine A sine B minus sine A sine B becomes 2. So 2 sine A sine B is equal to, now we are subtracting 3 from 4, so it becomes cos into bracket A minus B, and then minus cos into bracket A plus B. So if we make sine A sine B the subject, it becomes half of into bracket cos into bracket A minus B, then minus cos into bracket A plus B, bracket close. So we can do the same thing too for equation 1 and equation 2 by subtracting equation 2 from equation 1. So equation 1 minus equation 2. You see that when we do that, this side will go to 0. Sine A cos B and minus sine A cos B is 0. And then cos A sine B minus cos A sine B becomes 2 cos A sine B. And that is equal to, now we are subtracting equation 2 from equation 1. So it becomes sine into bracket A plus B, and then minus sine into bracket A minus B. So if we make cos A sine B the subject, then we get that cos A sine B is half of into bracket sine A plus B, then minus sine into bracket A minus B. Now these four equations, which are this equation, so let me label this as small a, and then this equation small b, and then this equation small c, and this equation small d. A, B, C, and then D are the equations that are going to help us to be able to do integrations of this form. So we have this question here, which is integrate 2 sine 2x cos 3x dx. So you see that the integral is of the form sine A cos B. So you see sine A cos B, and that is half of into bracket sine A plus B plus sine A minus B. So that is sine A cos B is equal to half of into bracket sine into bracket A plus B, then plus sine into bracket A minus B, bracket close. So what it means is that the sine 2x, this 2x is A, so A is equal to 2x, and then the cos 3x, this 3x is B, so B is equal to 3x. So now the integral, this is a constant, so I'm bringing it out of the integral. So the integral becomes 2, and then now we want to replace sine A cos B with half of bracket, then sine A plus B, which is sine, then A plus B, which is 2x plus 3x, and that is going to give us 5x, and then plus sine into bracket A minus B, which is 2x minus 3x, which is minus x. So then dx, so there's a dx here. Now these two and then these two can cancel out, so the integral becomes integral of into bracket sine 5x, and then now this is sine, the sine function is an odd function. What I mean is that sine minus A is equal to minus sine A. That is an odd function, and therefore sine minus x can become minus sine x, then bracket close dx. So let me continue from here. So the integral becomes integral of, we want to use the properties of limits and integrals to break this integral into two. So it becomes integral of sine 5x dx, then minus integral of sine x dx. Now remember what we said, integral of sine nx dx is equal to minus 1 over n, and then cos nx. So we are going to apply the same here. What did we do? We differentiated what is inside. If you differentiate 5x, you get 5. So it becomes, so integral of sine 5x dx is minus 1 over 5, then cos 5x, and then minus integral of sine x is minus cos x. Then because these are indefinite integrals, we need to add a constant of integration. Therefore, this becomes cos x, because this is minus minus, so it becomes plus. So cos x minus 1 over 5 cos 5x plus c. So therefore, integral of 2 sine 2x cos 3x dx is equal to cos x minus 1 over 5 cos 5x plus c. So we have another question here, which is integral of cos x cos 2x cos 4x dx. So you see that the integral is of the form cos a cos b, and then cos a cos b is half of into bracket cos a plus b plus cos a minus b. So cos a cos b is equal to half of into bracket cos into bracket a plus b, then plus cos into bracket a minus b, bracket close. So now what we need to first do is that I want to write this integral as integral of cos x, then into bracket cos 2x, then cos 4x dx, so that we can use this to first solve cos 2x and cos 4x. So now this becomes integral of cos x, then into bracket half of, so in this case a is 2x and then b is 4x, so half of another bracket cos, now 2x plus 4x is 6x, so cos 6x, then plus cos a minus b, which is cos 2x minus 4x is minus 2x, so cos minus 2x, then bracket close. Let's close this bracket, then dx. So now this becomes integral of cos x, but I want to bring the 2 because 2 is a constant, so I want to bring, sorry, the 1 over 2, so I'm bringing 1 over 2 out of the integral, so cos, then bracket open. Now here is cos 6x, and then now cos function is an even function. Cos minus a is equal to cos a, because cos is an even function, and therefore cos minus 2x becomes plus cos 2x dx. So having done this, we can then break this integral into 2. So the integral becomes half, then integral of cos x cos 6x cos 6x, then plus half integral of cos x, then cos 2x dx. Sorry, there's a dx here. So we'll then have to then solve these integrals separately, but this is still of the form of cos a cos b, so we can still use this identity to expand this. So we reach this point, which is half of integral of cos x cos 6x dx minus half cos x cos 2x dx. So I want to first do integral of cos x cos 6x dx. Now we know that cos a cos b, just as we did previously, is equal to half of bracket open cos to bracket a plus b, and then plus cos into bracket a minus b, bracket close. So now this integral becomes integral of 1 over 2 bracket open cos a plus b. A is x and b is 6x, so it becomes cos x plus 6x is 7x, then plus cos a minus b, which is cos x minus 6x, which is cos minus 5x, cos minus 5x. However, cos is an even function, so cos minus 5x is the same as cos 5x. So this becomes, I want to pull this half out, so it becomes half integral of cos 7x, so let me bring the bracket, cos 7x plus cos 5x, bracket close, dx. So if you integrate, let me bring this half out. If you integrate cos 7x, it becomes 1 over 7 sine 7x. And then if you integrate cos 5x, it becomes plus 1 over 5 cos, sine 5x. Now, when we finish the second part, then we can then add the constant of integration. So we are done with this part. So let's do this part. So that part is integral of cos x cos 2x dx. So using the same expansion, it becomes integral of half of bracket open cos a plus b, which is cos x plus 2x, which is cos 3x, and then plus cos A minus B, which is cos x minus 2x, which is cos minus x. But cos is an even function, so cos minus x is cos x, bracket close, dx. So I'm pulling the half out, so it becomes half of integral of bracket open cos 3x then plus cos x, bracket close, dx. Now when you integrate cos 3x, so let me bring half here, bracket open. When you integrate cos 3x, it's 1 over 3 sine 3x. And if you integrate cos x, you get sine x, so plus sine x. So you can see that there is a half here and then there is a half here, but there was already a half here. So this integral becomes the integral of cos x cos 2x then cos 4x dx is equal to, I want to pull out half, so let me write it down here, bracket open. But there's already a half here, and that half will multiply this half, so we will get 1 over 4. And there's also a half here, and then there's a half here, so it becomes 1 over 4, then bracket open. Here is 1 over 7 sine 7x, then plus 1 over 5 sine 5x, and then here is plus 1 over 3 sine 3x, then plus sine x, then plus a constant of integration c. So what if the integral is of the form of sine exponent nx dx, or even cos exponent n x dx, or even integral of sine exponent n x cos mx dx, where m and n are even. So let's take an example and then we can know what to do. Evaluate integral of bracket open sine 2x minus cos x, bracket close, all squared dx. Now, how do we go about this? The safest method is to first do the expansion. So this is equal to integral of, if you expand this, so sine 2x squared, so here sine squared 2x dx, and then so let me bring a bracket, and then minus 2 sine 2x cos x, and then plus cos squared x, bracket close, dx. So then let me continue from here. This is equal to, first let's break all of these integrals into single units. So it becomes integral of sine squared 2x dx, then minus 2 integral of sine 2x cos x, then plus integral of cos squared x dx. So there is a dx here and there is a dx here. So let's first start with this. What is integral of sine squared 2x? Sine squared 2x dx. So the way to go about this is to use the substitution sine squared a is equal to half of 1 minus cos 2a. So this can be expressed as half integral of, then into bracket 1 minus cos, the 2a becomes 2 times x, which is 4x dx, and this is equal to half, if you integrate 1 it is x, then if you integrate minus cos 4x it becomes minus 1 over 4 then sine 4x. So we are done with this part. Let's take let's do this part, then we will later do this one. So what is integral of cos squared x dx? Remember that we said that cos squared a from trigonometric identities is equal to 1 over 2, then half of, into bracket, 1 plus cos 2a. So this one is equal to integral of half of, into bracket, 1 plus cos, the 2a becomes 2 times x, which is 2x dx. So this is equal to, I'm pulling the half out, integral of 1 plus cos 2x dx. So now this is equal to half of, into bracket, if you integrate 1, it is x, and if you integrate cos 2x, it is 1 over 2 sine 2x. Now let's come to this one, which is integral of, let me write it down, integral of sine 2x cos x dx. So you can see that integral of sine 2x cos x dx is in the form of sine a cos b, which is half of, into bracket, sine a plus b plus sine a minus b. So this is, let's use sine a cos b is equal to half of, into bracket, sine, into bracket, a plus b, then plus sine, into bracket, a minus b, bracket close. So the integral becomes integral of half, so I'm pulling the half out, then sine a plus b, a is 2x and b is x, so sine 2x plus x is 3x. Let me bring a bracket here, and then plus sine 2x minus x is sine x, then dx. So this becomes half, then if you integrate sine 3x, it is minus 1 over 3 cos 3x. If you integrate sine x, it is minus cos x. Now, so we now have all the integrals. We have integral of sine squared 2x, integral of cos squared x, then integral of 2x cos x. So now, this integral, let me write the final answer here. Integral of, into bracket, sine 2x minus cos x squared is equal to, let me write the answer down here. So now, sine squared x, the answer was, this is the answer for sine squared x. It is half, so half of x minus 1 over 4 sine 4x, and then minus 2, then integral of this one is 1 over 2, so times 1 over 2, bracket, minus 1 over 3 cos 3x minus cos x, bracket close, then cos squared x, and which is this one, then plus half of, to bracket, x plus half sine 2x, bracket close, plus c. So this is equal to, further simplifying, so you see that there is half x here and half x here. So if you add the two, you get x. Then apart from that, this half, a 2 will cancel this half, and therefore this becomes x, and then 1 over 2 times 1 over 4 becomes minus 1 over 8 sine 4x, and then here is minus, so there's minus minus, so here is plus 1 over 3 cos 3x, then plus cos x, and then here is plus 1 over 2 sine 2x plus c. Sorry, it is not 1 over 2. This is half times half, so it is rather 1 over 4. So here is 1 over 4 sine 2x. Cases. Want to look at cases where integral of cos n x sine mx dx, where n and then m are odd. We look at the case where they were even. I want to look at cases where they are odd. What is the integral of cos cubed x sine x dx? So what we'll do is that let's let a to be equal to cos x. So dA in this case is equal to minus sine x dx. So this implies that dx is equal to minus dA over sine x. So the integral becomes integral of cos cubed x. Remember we said a is equal to cos x, so cos cubed x becomes a cubed, then times sine x. But dx, this is dx, it becomes times minus dA over sine x. So this sine x and sine x can cancel, so that we are left with minus integral of a cubed dA, and that is equal to minus 1 over 4 a exponent 4 plus c. Nonetheless, we said that we should let a to be equal to cos x. So a exponent 4 is cos exponent 4x. So integral of, so let me write it well. Integral of cos cubed x sine x dx is equal to minus 1 over 4. So minus 1 over 4 a exponent 4, which is cos exponent 4x, then plus c. So now let's evaluate integral of sine exponent 5x dx. How do we do this? So let me rewrite this as integral of sine x and then sine exponent 4x dx. And then I can further write this as integral of sine x, then sine squared x all squared dx. Then from here, remember that we said that sine squared x is equal to 1 minus cos squared x. So I can introduce that here. So it becomes integral of sine x, then into bracket 1 minus cos squared x all squared dx. So when we expand this, it becomes integral of sine x, then expanding this, 1 squared is 1, then minus 2 cos squared x, then plus cos exponent 4x dx. So we can then break the integral into smaller integrals. So this becomes integral of sine x, then if you multiply by 1, then dx, so sine x dx, then minus 2 integral of sine x, then cos squared x dx, then plus integral of sine x cos exponent 4x dx. So if you integrate sine x, it's equal to minus cos x. So we are done with this part. Now let's do integral of sine x cos squared x. So integral of sine x cos squared x dx. So what we'll do is that let's let a to be equal to cos x. So dA is equal to minus sine x dx. Therefore, this implies that dx is equal to minus dA over sine x. So this integral becomes integral of sine x, then cos a is cos x, so cos squared x is a squared, and then dx, but dx is now minus, so times minus dA over sine x. So this sine x and sine x will cancel out. So this is equal to integral of a squared sorry, there's a minus here, minus integral of a squared dA. This is equal to minus 1 over 3 a cubed. Then when we are done, we will add the constant of integration. So we are done with this part. However, we said that a is cos x, so this is minus 1 over 3 then cos cubed x. So having done this, then we can do the last one, which is integral of sine x cos exponent 4x dx. So you can see that it is also of this form. So without continuing, I can just say this is equal to minus 1 over 5 cos exponent 5x, because here was squared, so it's minus 1 over 3 cos cubed x. So if here is exponent 4, it becomes minus 1 over 5 cos exponent 5x. So now we can then add all. So integral of sine exponent 5x dx is equal to sine x. If you integrate sine x, is minus cos x, and then minus 2 times, if you do all of this integral, that's this answer, so times minus 1 over 3 cos cubed x, then plus all of this integral is minus 1 over 5 cos exponent 5x, then all of this plus the constant of integration. So if you multiply these two, here will become positive, and therefore let's first write that. So this is equal to 2 over 3 cos cubed x, then minus 1 over 5 cos exponent 5x, then minus cos x plus c. Let's evaluate integral of sine exponent 5x and then cos squared x dx. So now I want to rewrite this as integral of sine x, then sine exponent 4x cos squared x dx. And then I can further rewrite this as sine x, then sine squared x all squared, then cos squared x dx. We know that sine squared x is equal to 1 minus cos squared x, and therefore the integral becomes integral of sine x, then this becomes 1 minus cos squared x all squared, then times this one cos squared x dx. So now let's expand this. This becomes integral of sine x, then 1 minus 2 cos squared x, then plus cos exponent 4x, then times cos squared x dx. So we can then use this to break the integral into smaller integrals. So this then becomes integral of sine x cos squared x dx, then minus 2 integral of sine x, then cos squared x times cos squared x is cos exponent 4x, then plus integral of, sorry, there's a dx here, integral of sine x, then cos exponent 4x times cos squared x is cos exponent 6x dx. So now we need to solve all of this independently. So let me do that here. What is integral of sine x? Sorry, what is integral of sine x cos squared x dx? So let a to be equal to cos x. So dA is equal to minus sine x dx. So this implies that dx is equal to minus dA over sine x. And therefore, this integral becomes integral of sine x, then cos squared x becomes a squared, then dx becomes minus dA over sine x. So this and this one will cancel out. So this becomes integral of, so there's a minus sign here, minus a squared dA which is equal to minus 1 over 3 a cubed, and that is minus 1 over 3. A is cos, so cos cubed x. So you can see that this is all of this form. Now let's use this understanding to write the answers for the rest of them. So this means that integral of the second one, sine x cos exponent 4x dx, will be equal to, here was sine x cos squared x, and we got minus 1 over 3 cos cubed x. So you see that the squared was plus 1 and it became cubed divided by 3. So that means that this 4 will become plus 1, will become 5. So that will give us minus 1 over 5, then cos exponent 5x, and then integral of sine x cos exponent 6x dx will become, so you add 1 to the 6, which will be 7, so minus 1 over 7, then cos exponent 7x. If you go through these previous steps, you get all of these answers. So therefore it implies that integral of sine q exponent 5x cos squared x dx is equal to this, and this evaluates to minus 1 over 3 cos exponent 3x, and then minus 2 times this evaluates to minus 1 over 5 cos exponent 5x. Then this is plus, so that will evaluate to minus 1 over 7 cos exponent 7x. So if we further simplify this, this is minus 1 over 5, so it becomes 2 over 5 cos exponent 5x, then minus 1 over 7 cos exponent 7x, then minus 1 over 3 cos exponent 3x, plus the constant of integration c. So what is the integral of tan squared x sec squared x dx? So what we do is that let's let a to be equal to tan x. So the a is equal to, if you differentiate tan x, you get sec squared x dx. So this implies that dx is equal to dA over sec squared x. So the integral becomes integral of, now a is tan x, so tan squared x is a squared, then times, sorry, there's a sec squared x here, then dx becomes dA over sec squared x. So this and this one will cancel out. So the integral becomes integral of a squared dA, and that's equal to 1 over 3 a exponent 3 plus c. But a is tan x, so it becomes 1 over 3 tan cubed x plus c. So let's integrate integral of tan cubed x sec exponent 5x dx. So what we will do is that I want to rewrite this as integral of tan x, then tan squared x, then sec exponent 5x dx. But then we know that from trigonometric identities, 1 plus tan squared x is equal to sec squared x, and therefore tan squared x is equal to sec squared x minus 1. So the integral becomes integral of tan x, then into bracket sec squared x minus 1, and then times sec exponent 5x dx. So we can then break this integral into 2. So it becomes integral of tan x, then sec squared x times sec exponent 5x becomes sec exponent 7x, then minus integral of tan x, then sec exponent, so here becomes sec exponent 5x dx. So let's evaluate these integrals independently. So what is integral of tan x sec exponent 7x dx? Sorry, there's a dx here, so dx sec x. So dA is equal to, if you differentiate sec x, it is tan x sec x dx. So this implies that dx is equal to dA over tan x sec x. So I can rewrite this integral as integral of tan x and then sec x. Sec x. Then I pulled out one sec x, so we are left with 6. So sec exponent 6x dx. And therefore, this becomes integral of tan x sec x. Then the sec is a, so sec exponent 6x becomes a exponent 6 times dx becomes dA divided by tan x sec x. So tan x and sec x will cancel out, so it becomes integral of a exponent 6 dA, and that becomes 1 over 7 a exponent 7. But we said a is equal to sec x, so this becomes 1 over 7 sec exponent 7x. So let's evaluate this one too, which is integral of tan x sec exponent 5x dx. So let a to be equal to sec x. So dA is equal to tan x sec x dx. So this implies that dx is equal to dA divided by tan x sec x. So now I can rewrite this as integral of tan x sec x then sec exponent 4x dx, so that the integral now becomes integral of tan x sec x, then sec exponent 4x becomes a exponent 4, then times dA divided by tan x sec x. So this and this will cancel, so this becomes integral of a exponent 4 dA, and that is equal to 1 over 5 a exponent 5. But then a is equal to sec x, so this is equal to 1 over 5 sec exponent 5x. So therefore this integral becomes, now when we did this, we got 1 over 7 sec exponent 7x, that is this answer. And then when we did this integral, we got 1 over 5 sec exponent 5x, so it becomes plus 1 over 5 sec exponent 5x. So this is the answer to this integral. Evaluate the integral of cot exponent 3x then cosec exponent 7x dx. So what we will do is that let's rewrite this as integral of cot x then cot squared x then cosec exponent 7x dx, so that we know that from hyperbolic identities 1 plus cot squared x is equal to cosec squared x. So it implies that cot squared x is equal to cosec squared x minus 1. So the integral becomes integral of cot x then into bracket cosec squared x minus 1 then times cosec exponent 7x dx. So we can break this integral into 2. So it becomes integral of cot x then cosec, now this is squared, this is 7, so it becomes 9x minus integral of cot x then cosec cosec exponent 7x dx. So let's take all of this and evaluate them separately. So integral of cot x cosec exponent 9x dx. Sorry, there's a dx here. So let's let a to be equal to cosec x. So dA, if you differentiate cosec, you get minus cot x cosec x dx. So this implies that dx is equal to minus dA divided by cot x cosec x. Now I can rewrite this integral as integral of cot x. Then I'll pull out one of the cosec, so cosec x. Then the remainder becomes cosec exponent 8x dx. And therefore this becomes integral of cot x cosec x. Then cosec exponent 8x becomes a exponent 8. Then the x becomes the a divided by cot x cosec x. So this and this will cancel, and this will give us integral of a exponent 8 dA. But there is a minus here, so sorry, here's minus dA. So we pull out a minus here. That will give us minus 1 over 9 a exponent 9. That's equal to minus 1 over 9 cosec exponent 9x. So having gotten that, let's evaluate integral of this one, which is cot x cosec exponent 7x dx. Now using this understanding, we can evaluate this. You can see that when we did this cot x cosec exponent 9x, we got minus 1 over 9 cosec exponent 9x. So when we do this one too, we'll get minus 1 over 7 cosec exponent 7x. And therefore integral of cot exponent 3x cosec exponent 7x dx is equal to minus 1 over 9 cosec exponent 9x minus 1 over 7 cosec exponent 7x plus c. Sorry, I made a mistake. Here is minus. So because there is a minus here, then here will become minus 1 over 7 cosec exponent 7x. So the final answer becomes 1 over 7 cosec exponent 7x, then minus 1 over 9 cosec exponent 9x plus c.